Hello viewers, welcome to CEC lectures. Myself Dr. Priti Jagwani from Aryabhat College, University of Delhi, and in this present lecture of mine we are going to discuss about the network layer. So, let me help you recall. In my previous lecture we talked about the functionalities of some of the functionalities of network layer, which are related to kind of logical addressing, then forwarding we have seen. Other functionalities we are going to cover in this current lecture. So, moving forward, in the previous lecture we looked into the difference of the routing and flooding, and here we are going to take that the next functionality of the network layer. So, the next functionality of the network layer is about fragmentation and reassembly of packets. So, when I am saying fragmentation and reassembly, fragmentation, as the name suggests, it splits the large packet into smaller fragments. Why it is required? In order to match the maximum transmission unit of a network. So, maximum transmission unit is MTU, and then it is needed to be reassembled at the destination end. Now, in case of if the size of the packet is going to be larger than the maximum transmission unit of a network. So, for example, maximum transmission unit of a network is, let us say, I am just taking an hypothetical example, is 500 kb, and your packet is having kind of a size of 1000 kb, then that has to be kind of divided into smaller packets. So, fragmentation, and then at the destination end those packets are needed to be reassembled again. So, that is fragmentation and reassembly, because each network has an MTU, which is maximum transmission unit, and that basically defines the largest packet size that network can handle. And if the packet exceeds the MTU, the network layer is going to fragment the packet into these smaller pieces, we can say, and then those pieces will be added on with the different information, which is kind of we can say header, and this header is added to each fragment for identification and sequencing, because sequence number is also being kind of added to that. At the destination, the fragments are reassembled into the original packet, and this whole process actually ensures the compatibility with network of varying capabilities without data loss. So, this without data loss is actually kind of an important thing. So, here if you can see, we have a packet which is going through a network 1, and then network 1 is having kind of two gateways. One is G1, another one is the exit gateway, which is G2. Now, there are kind of some fragments created by G1 and they are addressed to G2. So, here the fragmentation has happened, and after kind of coming out or after exiting from this network 1, they are kind of again reassembled by G2 to create that complete packet, which was kind of there in the inception. Now, if it is going to enter into the network 2, let us say here is a gateway which is 3, and then this gateway 3 is going to divide that packet into 3 pieces, and the earlier these pieces were kind of more than 3, we can say 6 pieces it was divided. So, all those these pieces are actually a layman terminology, but it is easy to understand. So, G3 is going to kind of fragment these that packet into, let us say, 3 pieces, and then it is addressed to G4, and G4 is going to be finally kind of reassembling them, and final the packet is created by G4 by reassembling those 3 segments. So, the network 1 is having a less MTU, that is why the more fragments were there, while your network 2 is having a kind of a better, or we can say a higher MTU, and hence the number of fragments is a little lesser, we can say. Moving further, if we talk about these as I was saying, this pieces are actually a layman terminology. In computer networks, if we talk about the exact term, that data which is sent in small units is called packets or datagrams. Sometimes these datagrams are too large to pass through a network, and that network is having a smaller MTU. In order to handle this, that datagram is broken into smaller parts, and that is what your fragmentation is, and that we have seen. So, general terms, if we look into this, IPv4 datagram size can be up to 65,535 bytes, and I have told you that every network has an has a MTU limit. Fragmentation is kind of splitting large in this. Each fragment is having its own header, otherwise they will not be able to we can say reassembled properly at the destination end, and fragmentation can occur at the source or the router. We can say reassembly obviously is going to happen at the destination end. So, this fragmentation and reassembly was also one of the a major task of your network layer. In this whole, one thing, one functionality which comes up is subnetting. Subnetting is kind of, dividing a network into its subpart, or we can say dividing the large networks into smaller subnetworks, and this is done in order to ensure the efficient addressing and the traffic management. So, logical subnetting, if we look into, so here we have a figure which is explaining the logical subnetting. So, on the left side, this is a kind of a self-explanatory figure. On the left side, we have a big single network, and if we are going to subnet it, it is going to be divided into kind of 4 subnets. So, this you can see in this figure. So, logical subnetting is also a functionality of your network layer. It involves dividing a large IP network into a smaller in the sense more manageable subnetworks, and this subnetting is going to help in improving the network performance by reducing the congestion. Obviously, the congestion is reduced because now you have divided the whole network into 4 parts, or some logical parts, and then your data can flow through. This subnetting will help in enhancing the security by isolating the part of networks. Not only this, this subnetting will also simplify the network management and troubleshooting because of this we can say modularity. Subnetting uses subnet mask to define the range of IP address within each subnet. So, for example, the IP addresses, I am taking an example, from A to C belongs to subnet 1, then from D to F belongs to subnet 2, and this is going to be within the total pool of those IP addresses which are already kind of fixed or assigned, we can say. So, subnetting uses subnet mask to define the range of IP addresses within each subnet, and this will enable efficient address allocation and routing. Next functionality of your network layer is NAT, NAT. So, that NAT stands for Network Address Translation. Now, let us try to understand what is this network address translation. So, as the name indicates, this requires some kind of translation of the network address. So, when I am talking about network address, this is the IP address. So, NAT is basically a method of mapping private IP addresses within a local network to a single public IP addresses and vice versa. So, what is this NAT? Let us try to look that into the detail. So, it actually maps private IPs to public IPs, and this is done in order to make an efficient internet communication, conserving the address space, and also adding extra we can say securities. So, this net facility allows multiple devices in a private network to share a single IP address for internet access. And how one is going to achieve this? These translating the private IP addresses to a public IP address for outbound traffic. So, for example, in a kind of a in a local area network in an office, or the private IP addresses are being assigned to the devices, but when the traffic is kind of being sent to the outside network, we can say this network or this system is using an public IP address for outbound traffics. And also this process has to be reversed for inbound traffic also, that is kind of we can say very obvious. Also, if we look into various benefits of this network address translation, this helps in conserving IPv4 addresses by reducing the need for unique public IPs for each device. So many private IPs are being mapped onto one public, or we can say on a lesser number of public IPs. So, this this is the benefit where we can conserve IPv4 addresses, because the need for the unique public IPs for each device has been kind of reduced to maybe a single device, or maybe a few or little lesser number of devices. Obviously, an extra kind of layer of security is being kind of added by masking the internal IP address from the external networks, because now your external network can only see your public IP address, not the all those private IP addresses which are assigned to each and every individual device. So, basically it has enhanced the security by masking internal IP addresses from the external networks. And if we want to kind of look into this figure again in order to understand the process of network address translation. So, here on one hand you can see a public network, it has been named as kind of internet. Now, the public IP address is 244.46.1.1, and when it has been changed into a private IP address, or it has been mapped, we can say, onto a private IP address. That private IP address has become is 174.122.1.1, and within that private IP address, the different devices which are attached to this network on which this router is operating. So, on the left side you can see there is a smartphone, then there is a computer, there is a tablet. So, different devices. So, all those devices are now having 174.122.1.4, then 174.122.1.3, and then 174.122.1.2, which is kind of in a way masked or masked private IP addresses. And now your outer world is not able to kind of access or see, we can say, those directly those private IP addresses, because your public IP address which is on the display is 244.46.1.1, and this is going to happen on for the outbound traffic and for the inbound traffic both. So, till this point, including this lecture and the previous one, we have looked into so many functionalities of the network layer into onto a greater length of detail, if we can say. Now, if we talk about what are the advantages of all these services which we talked about, is one is packetizing services in the network layer provides the ease of transportation of the data packets. Also, the packetization eliminates single point of failure in data communication system. That is also a kind of, we can say, a remarkable advantage. Now, routers which are present in the network layer, they reduces the network traffic by creating separate broadcast domains, or maybe kind of we can say collagen domains. So, all these, by separating all these areas, the routers which are present in the network layer, they are going to reduce the network traffic, and with the help of forwarding, the data packets are transformed from one place to another in a network, or maybe kind of across the network. So, these are kind of basic functionalities of the network layer, and I hope I am able to establish this importance of the network layer services or the network layer. Now, if we we have looked into the advantages, now coming the next side of the coin is disadvantages. Disadvantages of the network layer services says that flow control is absent in the design of the network layer, because flow control is not kind of mentioned, or it has not been taken care of. Also, sometimes due to presence of too many datagrams in a network, congestion occur, because what happens is, beyond the capacity of the network or beyond the capacity of the routers, if so many datagrams or too many datagrams are present in a network, it is going to overwhelm the whole router, or it is going to overwhelm the whole network, and congestion is then bound to happen. Because of this congestion, in order to mitigate this challenge, some of the routers may drop some of the datagrams, and hence there is a possibility of losing some pieces of kind of important information, or some pieces of information may be lost in order to kind of in order to solve this challenge of congestion. So, this congestion is a challenge for network layer services, also the lack of flow control. Although we can say that indirectly error control is present in the network layer, but not directly. There is a lack of proper error control mechanism, as due to the presence of fragmented data packets, error controls becomes difficult to implement. So, so much so many fragments of the data packets are there. So, it is not easy to implement, or it is not easy to achieve error control at this point of time. So, error control, flow control, then we have congestion. All these are we can say these are the challenges of your network layer services. Now, with all these functionalities in mind, or with the understanding of all these functionalities, let us look how these kind of network layers is actually going to work. So, in order to understand this, let us have a look on this figure. So, basically your network layer is responsible for communication of these packets from here to there, if we can say, or from a network to another. So, in this figure, if you can see, there are kind of 4 networks A, B, C and D, and these 4 networks are having those internetworking devices. We can say simply we can say routers. Now, let us say from network A, one machine sends a packet which is intended for, let us say, network D. So, that packet, how that packet will travel the whole path, that determination of the path is actually the job of the network layer. So, let us see how your network layer works. So, each device here is assigned a unique IP address, which is, we are calling them logical addresses. Data from the transport layer is encapsulated into packets with source and destination IPs attached, and some of the important information with this payload. Then routers are going to analyze the destination address and determine the best available path. Now, there can be multiple paths from source to destination. So, for example, there is a path which is from A to D direct, and there is a path which is going from A to B and then from B to D, but at that particular time that path from A to D is full of congestion. So, the best path which can be adopted is from A to B and then from B to D. So, that kind of we can say decisions are to be taken. Then packets traverse the network hop by hop, that means moving across the routers of one network to another until it reaches the destination router. Also, the thing which is to be taken care of is if the packet size exceeds the MTU, it is a fragmentation facility is also needed, and if it is there, that at the destination the fragments are again reassembled into the original data. If the error occurs, let us say if it is kind of giving an error of unreachable destination, then protocols like ICMP, we will be covering them, sends the error message back to the source. Now, for all this kind of functionalities, we have so many protocols which are operating at the network layer. So, in this lecture I am just going to name them because of the paucity of the time, and in my further lectures we will be definitely covering some of the important protocols among this. So, let us look at the listing first. So, this says IP, which is internet protocol, could be IPv4, IPv6 depending upon the older and the newer version. Then ICMP I just mentioned, which is internet control message protocol, address resolution protocol, because addressing is the mechanism which is adopted here. So, obviously ARP is required. Then corresponding to address resolution, reverse address resolution is also required, and hence the protocol RARP, which is reverse address resolution protocol. Then network address translation and a protocol for this NAT protocol. Then IPsec, which is internet protocol security, and MPLS, which is multi protocol label switching. So, all these rules, all these protocols are being operated at the network layer. Particularly if we talk about routing protocols, so we have RIP, which is routing information protocol. Then we have OSPF, open shortest path first, and another routing protocol which is kind of we can say very famous or a prominently used one is BGP, which is border gateway protocols. So, these are just the routing protocols, and the previous list belongs to all the protocols which operates on the network layer. So, we have seen whatever the functionalities are there. We also looked into limitations, which is kind of flow control mechanism is missing. Congestion is kind of an indispensable part of this whole process, because too many datagrams can be there in transit. Error control facilities are also kind of missing because of this overwhelming congestion. Your routers may drop the packets if they are under kind of heavy load, and this will definitely lead to the possible data loss. And fragmentation, if we talk about, it actually increases the processing overhead and it will affect the performance. So, absence of all these solutions of all these changes at the network layer bring out some of the limitations, but yes, with all these functionalities we need to acknowledge that network layer is having its own importance in this OSI model, because this is the first layer which is looking into kind of end to end delivery. So, that is what it is. The layers below which are there, for example, data link layer, it is giving you a delivery, it is giving you a delivery from hop to hop, not from end to end. So, in this lecture we looked into some of the functionalities of the network layer, which are kind of network address translation, then fragmentation and reassembly and so on and so forth. Then we also looked into what is actually your what are the advantages, what are the disadvantages, what are the limitations, that means what kind of services are there which are not available on these under these network layer services. And we also looked into some of the listing, or some of the names of the protocols which are which operates at these network layer in not only the network layer, but specifically routing protocols listing we have also looked into. More about these protocols in my upcoming lecture. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.